Hey, welcome back, y'all. So the week before we left on that awesome week that we had off, we talked about scale factors and we were talking about ratios and similar figures. Well, today we're going to do kind of like what we did with congruent triangles, and we're going to use different proofs, different theorems, to prove that two triangles are in fact similar. So again, remember the difference between congruent means equal and similar means same shape, same angles, but the side lengths are proportional. They can be set up in a ratio. And so the symbol we use for congruent is, of course, this equal sign with a little loop-de-loop on top of it. And then the symbol we're going to use for similar is just a simple loop. Okay? And the definition of a congruent triangle are triangles. That's the symbol for triangle. It's also a symbol we use to read the change of. Triangles that have the same angles and sides. So the sides and the angles are the same. Now, in contradiction to that, similar triangles are triangles that have the same angles, however, the sides are proportional. And that's where we do that little new over. All right, so your scale factor for congruent triangles is always going to be equal to 1 because you have the exact same figure. Now, for similar triangles, the scale factor, if it's greater than 1, yeah, you have an enlargement. And if it's less than 1, but of course it has to be greater than 0, then you have a reduction. So that means the shape gets smaller. And how do you prove this? Well, these are postulates that you prove. We've got the side, side, side postulate. We've got the side, angle, side. Remember those 5? Angle, side, angle. No ASS. Ha, ha, ha. I had to get it in there one more time. AAS and the HL. That's only for right triangles. To prove for similar triangles, we're going to look at 3 different theorems. So these were postulates. Now for similar triangles, we're looking at theorems. We're going to look at the SSS. If 3 sides are proportional, the 2 triangles are similar. Side, angle, side. If the angles are the same, but the 2 sides are proportional, then the triangles are similar. And if you know 2 angles are the same, then you can also say that the 2 triangles are similar. So let's look at some examples of how we can apply these theorems. If you didn't get all the notes, pause the video and get all the notes in. Okay, so the similarity theorem of side, side, side says that there are 3 pairs of proportional sides. So hold on. So if we look at this, we see that the triangle, we're trying to prove that triangle ABC is similar to triangle DFE. And remember, these have to be in proportional, so I can see that, or corresponding. Angle A corresponds to angle D, so on and so forth. So what I look at is I first look at, let's say, the pink side. So I'm going to look at this side here, and I'm going to say that 5 over 4, so this is, I'm labeling this my new triangle, and this would be my new one in this example, and this one's my old. So I'm saying 5 over 4 is equal to 1.25. And if I can get that same ratio for all the other side lengths, then I know that my triangles are similar. So I'm going to look second at the green side. So that's 12 over 9.6. And when you divide that out, you get 1.25. Now I'm going to look at the orange side, 13 over 10.4. And that also equals 1.25. And so I can say, because of SSS theorem that these two triangles are going to be similar. Another examples, let's look at side angle side. So again, this time we're proving, is triangle GHI, and again I'm using this symbol because I'm not to get it confused with being congruent. They are similar to triangle LKJ. And if I look, I can see that G here is in the same position as L here. And then you just go around the triangle. Now notice, these angles are exactly the same. So first, I know that the angle measures are congruent. So I know that angle H is congruent to angle K. And you can see that they're both in the same position when I named the triangles. So I can say they're congruent because it told me. Now I got to find out if the sides are proportional. So I'll start with the pinkish purple side. And I'm going to label this my new triangle. This would be my old triangle. So I'm going to do 5 over 7.5. Divide that out. And I get 0.6. Now I'm going to look at the green side. And again, I have to put the new one on top. So 7 over 10.5. And again, I end up with 0.6. So I can say yes. These two triangles are in fact similar because of the theorem side angle side. And notice the two sides have to make the middle angle. All right, the next theorem is the angle theorem. And so what I can see is that if two pairs of angles are congruent, then the triangles are congruent. What you can see here is these two. So I'm going to say triangle NOM is congruent to triangle RPQ. And I know this because angle N is congruent to angle R, and angle O is congruent to angle P. And when I name them, you can see that those are in fact in the same position, so they're corresponding angles. And so I can say again, yes, these will be congruent. And in fact, I can actually determine what this other angle is by adding 70 plus 50, which gives me, let's see, 120, and subtracting that from 180. I know that the third angle of both of these is going to be 60. Just saying. All right, so those are the three theorems we're going to use to prove triangle similarity. And so remember, there's sometimes things that are hidden within a picture that you got to use what you know about triangles and parallel lines, etc., to determine this. So the first thing we're going to see if we can come up with a similarity statement. So let's remember that these sides here, because of that arrow, these sides are parallel. So what can I say about this is I can say that if this is my transversal line, alternate interior angles are congruent. And what else can I say about this? Well, I can say that these are a pair of vertical angles right here. And so I know that vertical angles are also congruent. And so because I have angle, I'm going to call this AEB, is congruent to angle CED, and that I know that angle B is congruent to angle C, I can say for certain that this is angle, 0. So yes, these are congruent. All right, let's move on to number 2. Again, what do I know about these two angles? Well, all they told me is that angle L is congruent to angle O, and KL is congruent to NO. But that's just an angle and a side. And if you just have an angle and a side, you can't say that these are similar. So we don't know for certain if they are similar. We can't prove it. All right, over here, what do we got over here? Woo, a lot of stuff over here. So again, we know this angle and this side. But because there's no arrows on these lines, I can't prove that, you know, there's corresponding angles or vertical angles or any of that. There are vertical angles here, and this again is angle side, so I can't say for certain if these are similar, because that's not one of my theorems that I just learned. All right, let's look at this one here. All right, we got to first see, are my side lengths proportional? And so what I see is I see this side length right here. So I'm going to say 28, so I'm going to call this my new, and I'm going to call this my old triangle. And I'm going to put 28, this side here, corresponds to this side here, over 14. And that gives me 2. And then I'm going to go ahead and take this side here and put it over this side here. So that's 10 over 5. And so that's 2. And I can say for certain that this angle here, angle V, is congruent to angle X because they're both right angles. You see that here. And so because of side, angle, side, yes, I can say that these triangles are proportional. Okay, let's look at some more examples. Here we go. Number 3. Now this is what we call an overlapping triangle. So the best thing to do is to actually separate these two triangles out. You can see this small triangle here. So I'm just going to redraw it, P-O-N. And then we've got this larger triangle here. And we're going to call, I'm going to just draw that here, M-L-N. Well, one thing I can say for certain is this angle N, because they overlap, those are going to be congruent, right? And then I've got these parallel lines here. And so because these are marked parallel, and I see a transversal line, I can say that this is going to correspond to this. So those are going to be corresponding angles. And so now I have my two angles. I've got angle P and O is congruent to M and L. And I've got that angle L is congruent to angle O because of corresponding angles. Remember, this angle can slide onto this angle. And so I can say that, yes, triangle MLN, oops, not that symbol, is congruent to triangle PON because of angle theta. All right, let's look over here. Well, this one I'm assuming I'm going to be proving based on sides because they gave me 3 side lengths on both triangles. So again, I'm going to call this my new, and this is my old. So I'm going from small to large. And I'm going to just go ahead and test to see if they make proportions. So I see that this side corresponds to this side. So I'm going to say 30 over 15 is equal to 2. And I'm going to say that this side, 26, and I only have to do it once because they're the same side lengths. This is a, what do we call that? Sides are the same. Isosceles triangle, that's right. And so this one is also equal to 2. So I can say that yes, because the triangles are, the side lengths are proportional, I can say that this triangle LMN is similar to triangle OQP. And that's because of side to side to side. All right, last one. We want to know if these are congruent. And again, they gave me 3 side lengths, so I'm going to have to look. The first I'm going to look at is AB and HG. So AB is here, and HG is here. So I'm going to call this my new, and this my old. So that's 72 over 12, which equals 6. I'm going to look at BC here, and GF. So BC is here, GF is here. So this is 48 divided by 8, and that is also 6. And then lastly, I do have to look at all 3 sides. I'm going to look at this side here, and this side here, which is 84 over 14. And if you divide that out, you also get 6. So yes, I can say yes because of side, side, side. If the 3 sides are proportional, then the angles are as well. All right, stay tuned for some word problems.